In this video, we're going to take a look at a new challenge that I made called Ultimate Calculator 3000, and I host this on my Discord server, so if you want to stay up to date on future challenges, you can join there or just keep an eye on my social media. And I'm going to try and get through this pretty quickly because I want to cover a lot. It's not that difficult of a challenge, but it combines a couple of techniques from different categories. So anyway, you join the Discord server, you'll download this file called Ultimate Calculator, and it's a 64-bit binary. You can see that it's stripped, which means if we're going to want to reverse engineer it, we're not going to be able to see function names, things like that. It'll be a little bit harder. It's also got pi enabled, so the function addresses will change, just the offsets will stay the same. And we'll also check the binary protections enabled. We want to get an idea, is this going to be a binary exploitation challenge? And it has most of the protections enabled, so canaries to prevent buffer overflows, NX to prevent shellcode execution on the stack, pi, which we just discussed, to randomize the addresses, so you would need to leak something. So most of the protections are enabled. We could have full railroad here as well, but that's kind of a hint that it's probably not going to be a pwn challenge, and if it is, it's going to be a very difficult one, or it's not going to involve the stack buffer overflow or something. Anyway, just a quick overview. Another thing we could do is check LDD. So if we do that, we'll actually see quite a lot of libraries this time. Normally you'll just see like libc and stuff attached, but in this case there's HTTP2 and there's also curl. So it's worth checking that because now we know that we want to be on the lookout for HTTP connections and any calls to curl. Alright, and I think that's about it. Let's just try and run the binary. Oh, I copied that somehow. Yeah, let's try and run it. It says we can use the calculator. We can check the serial for a professional feature, and we can check about and quit. So, alright, let's do about first. Nothing, just says we can go back, give some information about it. Calculator, let's try and do 1336 plus 1. There we go, we've got the result, and that's it. We can keep doing that, we can quit, or we can go back to the main menu. And then we have a quit option. I'm not going to use that because it's just going to quit the program. The final one is the check serial, which sounds interesting, right? And it's mentioned in a professional feature. And if we click on that, it'll say the feature is still under construction, so it doesn't actually seem to do anything. And at this point, I think the best thing to do is, we could hook this up to a debugger and have a look that way, but I'm going to open this up in Ghidra, and I have an alias set up here. People always ask me about it. You can get the bash aliases from my GitHub, and also this auto script. It's basically just going to skip through a lot of the auto analysis steps, so it's not really that much quicker, but it just takes a little bit less manual interaction. Okay, so as I mentioned earlier, the binary is stripped, which means we can't see the main function here. We start off at the entry, but we can just go to the first function that's called here. That's main, so I might actually just rename it as well. You can press L and then just type in the new name. And this is our main menu, as you can get an idea from the puts calls, and I'm interested in the under construction feature, which is here. And look, this is literally just looping through the menu options. So it's going to say press enter to continue, and that's going to go back. So the function does absolutely nothing at all. Alright, so we could go over to the functions here and just start having a look through them to see what's interesting. We could also have a search for some strings. So I'm going to search for strings and just go OK. And if we scroll through some of these, we'll see some things that we didn't see in the main function. So look at this, serial must be 32 hex characters. We have something mentioned in a flag here. We have serial auth tokens. Yeah, just click any one of these. Show references to the address. There we go. Alright, so this is where that string is used, is in this function. So again, you could have just gone through these. There weren't too many functions to look through, and if we saw this one, we would notice that there's a lot of variables being set up, and then there's some like obfuscation code here. You can see it's going for a loop and doing some shifts and some XORs, and it is using this value from the .data section here as well. And yeah, down here we can see what looks like an endpoint. So it's got /auth and /check. It's asking for a serial, and it must be 32 characters. If it is 32 characters, it's going to keep going. And then there's another function which is called down here, and if we double click on that one, we'll start to see the curl calls as well. So you could go and start renaming some of these. You could also go and just try and work through the obfuscation that's at the beginning. You could just copy and paste that output to ChatGPT, which is very nice at giving you the original source code, or just like adding comments and renaming variables and things. So there's some options. That's not what I actually intended to do. You can do that. I already spoke to some players. Actually, one was using a Mac, so they couldn't run the binary anyway, so they just did the whole thing like statically, which is totally fine as well. I would prefer to have the program do the hard work for us here. So we know that this function is 19A0. So one option is we could just patch the binary. I'll show a couple of ways to do this that don't involve the static analysis part. So let's go back to our main function. And if we go to the function call here, I'm going to go to right click and patch instruction. Okay, it takes a little bit of time to bring this up the first time, but after that it should go pretty quickly. And we can just replace the characters in here. So I changed the offset from 500, whatever it was at, and I'll change it to 9A0. Hit enter, and now you can see it's actually calling that function. Let's have a look at the decompiled code. There we go. So every time we do that menu option now, it's actually going to call the function that we're interested in, and all we need to do is export the program. Oh, I want to change the name though. Let me also just first change the type. We want this to be the original file type. So yeah, that's it. And then I'll change this to patched. We will save that. And let's go and try that out. So we'll need to do chmod, make it executable, the patched version. And now if we run ultimate patched, and it asks us for a serial, we press 2, and now it's actually asking us to put in a serial. So let's do 4 A's. A lazy way to do this. There we go, and it just went back to ask us the choice again. Presumably that means it wasn't correct. Let me see, can we just do that again? Yep, we can. Alright, let's try and do it with an incorrect serial. Yeah, alright. So that's one way to do it. I'm not going to continue with that method. Let's also look at another way. Let's use the original binary again. So gdb pwndbg I'm going to open with ultimate calc, and let's run the binary. It asks us for the menu option. I'm going to hit Control and C to pause it. And we're basically going to do the same thing. So we're not going to do the same thing. We're going to, rather than patch the binary, we're just going to manually jump to the function of interest. So I'm going to take a copy of this 19A0, and then we're going to, because the pi is enabled, we need to get the pi base. So you can do pi base and then the offset that you want, and it'll tell us this is the address that we want to go to. I think we can also now, let's do disassemble. Oops. No, okay. Oh, we can't do that. Alright, I thought we could. I don't know what I'm doing wrong there, but okay, doesn't matter. Let us jump to that breakpoint. So, not a breakpoint, and not jumped. Okay, demos never go very well. And now I need to do the A's again, so let's just do... There we go. Alright, and it came back invalid serial. Okay, now, again, we could go through and try and work out what's going on here. What I'm going to do instead is just have a look at the network traffic that's going on in the background, because we know it's calling curl. So let me open Wireshark, and I'll just capture on any interface. Let's do that again. We need to run Control and C, jump to that breakpoint, and then paste in 32 characters. There we go, invalid, and it came up with a lot of traffic. I'm going to stop the capture now. Filter by HTTP, and you'll see that there was 2 requests here. The first was auth, so we can follow the HTTP stream. Although you can already see it has a user and a password in there, which looks good. But yeah, let's follow it to get a clearer overview. And yeah, we can see it makes a post request to this subdomain on my domain with a user and a password. So maybe we'll note these down for later. We could put this into a script now to start manipulating it, recreating the behavior. And it gives back a token. And then let's go back. Let's filter by HTTP. We've got this one that came back with a bad request. Let's follow that. And we'll see, yeah, we sent off the serial. We also have the bearer with that token that we just got from the previous one, so presumably we'll need that. We send it off and it comes back bad request, so presumably we had the incorrect serial number. But if you notice the HTTP headers of the response, one of them is this link, which has a different subdomain. This is a different one to the subdomain that the challenge is on. And it also has an endpoint called serial and a title called backup, which sounds pretty interesting, right? So maybe we would take this and go to our browser, try and paste that in, see if we can access it. I actually can't, and I did see that some people were able to do this who solved the challenge. Essentially, and I didn't realize this until I was designing the challenge or testing it, is it's HTTP, but my web server is always upgrades to HTTPS, and I didn't want to make it HTTPS because as soon as you do that, people can just go to cert.sh and put in the domain, and then it would spoil the challenge because like those hidden subdomains would all of a sudden just be findable on here. You could just do CryptoCat.me and oh, strange. Okay, maybe the site is down at the moment or something. Anyway, that's not working, but what you can do is, I mean, well, we could use curl, right? Let's take a copy of this and let's do curl. Oh, I have the URL in twice. Okay, run curl, and yeah, it's redirecting us to login. So we want to try and play around with this, maybe do a Python script. Another option is you can just go to Burp Suite and have a look at the request here. Let's send that to the repeater, and I'll click on send. And it's not going to work because the target up here is HTTPS. So let's change that to HTTP. Let's try that again. And there we go. It's redirecting to login. So you could follow the redirection. There we go. We followed it to login. We scroll down and we'll see that there is a login form here. And it takes a username and a password. It says use your existing admin credentials. Now, we just got some admin credentials from the network traffic. So why don't we take a copy? Oh, it wasn't that one. Why don't we take a copy of this and okay, and go back to Burp Suite. I wish I could make this a better size so I could easily zoom in on it, but for some reason Burp Suite updated a while ago and it doesn't snap anymore in my... Oh, there we go, it snapped, right? Now watch. There's no like arrow to make this wider. Oh my god, now that's detached. That's just what I wanted. So I literally have to like do it like this and then from the bottom, but then quite often it doesn't go all the way across. It's really annoying when you're trying to make a relatively short video. Anyway, let's go back here. Let's change this to... You can also hide the headers here as well, just to get some of the nonsense out of the way. And we'll change the request method to post. And does it ask us for a username and a password here? No, it just goes back. Alright, let's do username equals cat and password equals, and then we'll paste in that password. We click on send. And now it redirects the serial, and notice that it's given us this new cookie. So before we redirect, we actually need this. So I'm going to go here and do cookie, paste that in, and then follow the redirection. And now it will... Oh, you can't do that. It actually got rid of the cookie that I just added. Let's do... Oh, it's a get request now, though. Change request method again to get, and we'll change it to serial. Yeah, it's probably better to do this with a script or something. Cookie is this one. Send. And there we go. We get through, and we're through to this support tools. Download the offline validator using vendor support, and it has another link. So I'll take a copy of this as well. Let's follow this along. Send. And now it actually downloads this binary. As you can see here, we've got an ELF as well, and the content types application / octet stream, and the file name is validator. So there are a few ways you could do this. You could just like copy all of this, I guess, and go and paste it and save it as another file. We could use a script to try and download it. What I'm going to do is just copy this as a curl command, which I can't remember where that is. Oh yeah, copy as curl command bash, and we'll go back to the terminal. Let me minimize Wireshark to get rid of the white background that we've got everywhere. Okay, and yeah, paste this in. The only thing is we don't want it to be -i because that will skip the body. And I'm going to do -o validator. And then let's have a look. File validator. Yep, there we go. We've got a binary. It's a Go binary as well, so we could make this executable. We could do the usual checks that we did earlier, but yeah, it takes the serial. I'm going to use some capital A's this time. Copy. There we go, invalid. So we've basically got a checker. We've got an offline checker. This is used by the support agents. I guess if the online service isn't working or some network issues, they can basically feed in a serial to this and it will tell you if it is valid or not. So if we've got a validator, that means we are a lot closer to making a generator. The only thing is, it's not very easy to analyze Go binaries in Ghidra. There are some extensions for it, and in the write-up to this, which I'll put on Gitbook, I'll leave a link to a guided hacking video where they try out some different IDA and Ghidra extensions, and you can get kind of back closer to the original pseudocode than if we just open it as I am now. Okay, with that open, we can go to the functions. We'll see it already. It's nowhere near as easy to work through this, but we're already through to main.main, so I guess we can go in here. Main.main, main.usage, main.verify serial hex. Sounds interesting. We can go in here, we can see the function calls like string to slice byte. We've got an encode, hex, decode, so it's decoding some hex string. And down here we've got a key salt. So, I mean, we could change the names of some of these. We can like say that's not alt, but yeah, we can change that to salts. And then we'll see that the salt is passed into this HMAC. So a new HMAC is created using the salt as a key. We can see it then has some hex looking strings in here. So you could also take these and go and like unhex them. I've got an alias in bash set up to do that. So this is reverse order. So you can see this is meow and this is cat : so it looks like it's building up the same username and password that we saw earlier in both of the web services. Then it's going to do some encryption down here. We've got some XORs. I know some people just work through this, just recreating the original code by using this. Another tip that I'll give apart from using the Go extensions for Ghidra is if you just literally take a copy of this, Control-C, just go and paste it into ChatGPT and say, give me the original Go version of this. Let me show what it comes out with. So I'm going to do a generator.go. Alright, I literally just copied and pasted that whole thing into ChatGPT and said, give me the Go version and give me the original Go code, and this is what it gave me. So basically, perfect, right? It's given us the user pass, it's given us the usage, it's given us all this verify serial hex, and it's even told us that we need to replace this with the key salts. That's the one thing that it couldn't find. And I mean, if you're using some like MCP tools, it would be able to like go and look through all of the different functions and things like that, and probably just get it right straight away. But yeah, in this case it doesn't. We need to get that salt. So let's go to main.keySalt, double click it, and then you'll see over here there's actually a pointer that's created, and you can just follow that along, and then you'll get through to this 32 hex character salt. And there's probably a lot of different ways you could get a copy of this. You could use like another tool in the terminal just to extract this from this part of the binary. What I'm going to do is just copy it. So you can go to copy special, and I think I want the byte string, no spaces. Is either that or is it raw? Let's see, let's take a copy of that, and I'm going to unhex. We've got a long hex string, we unhex it, and yeah, that's actually giving us back the original salt. So if I take a copy of that now, go over here and paste in the salt, alright, and then we can take a, oh, we don't have a valid serial yet to test. Alright, let me just take this just to see if this is even going to work. So I'm going to do, well, this is still, we're still using the validator, so I shouldn't really have called that generator. Okay, we're gonna redo this. We're gonna change it into the validator, but first we just need to have a look through this serial generation or serial verification so that we can then make the generator. I'm just going to copy over the same function but with some comments that I've added here to explain what's going on. It's going to create a HMAC, it's going to take in that key salt as the key for it, and then it's going to feed in the user pass. So it's going to feed in this part here, and then it's going to feed in the first 4 bytes from the serial number, and then it's going to finalize that HMAC, it'll get the digest from it, it's 32 byte digest, and then it's going to compare the first 12 bytes of the digest with the last 12 bytes of the serial. So the serial's 32 hex characters, that's 16 bytes, and essentially the first 4 bytes don't matter. So you could put in like any value there, and that's how we can have it so that the serial is unique each time, but is valid. We basically have this nonce at the start. So, just to recap, yeah, it creates the HMAC with a salt, feeds in the username and password, it feeds in the first 4 bytes of the decoded serial, and then it'll finalize it, get the digest, and then it's going to compare the first 12 bytes of the digest with the final 12 bytes of the decoded serial. And you can have a look in the write-up for a better explanation for the formula and stuff to do that, but essentially that gives us everything we need to make the generator. So, we're going to do an old school keygen, and I'm just going to paste in what I changed this to here. Let's have a look at it. It's got the key salt still. It is going to use a random 4 bytes, so we get a different serial each time. That's going to be the 4 byte nonce or the prefix. And then it's going to do the HMAC with the user pass, and it's going to pass in the Oh, sorry, I missed this part. So it was doing the user pass, and then it's writing the nonce as well. It's generating the HMAC, and then we've just got a main function which is just going to generate a serial number. So we can now go back and do go build and then -o generate or generator, and then it's going to take in that go file. And now if we do generate, oh yeah, we need to give it a serial number. Oh, what? That's not right. Let me... Oh, there we go. So yeah, every time we run generate, it'll give us a new serial number. So let's go and try one of them. We've still got the ultimate calc patched, so I'm going to go in here. I'm going to do check serial, and it says it's still in construction, but enter the serial anyway. And oh damn, okay, that patching wasn't a good example then. Let's go back to GDB. Let's run. And let's do Control and C, let's jump to that function, let's paste in that serial, and it says success, we get back the flag. And just to give you an idea, I have the server running here, so you can see the remote server, and yeah, we can see that it makes the auth request, it makes the check request, and they both come back 200 OK this time. And you can see all of the other requests that have come in here as well, like the accidental one where I pasted in the URL twice. And yeah, that's it. Alright, so, I mean, you could make a solve script at the end of this. I did a very simple solve script, so I just reused a template that I used from the OSWE. So, I didn't type all of this out. I basically copied and pasted an old script and then just went and modified it, which is how I kind of did the OSWE labs and exam. But yeah, this will just log in the user. It's going to create a session, it's going to log in, it's going to get that token from the... This is just from the second domain, so it's not actually it's just from the first domain. It's not actually touching the second domain that has the validator, because you can't really automate that, right? You can download the validator, but you still need to reverse engineer it yourself. Now, what you could do is improve this script a little bit, because I've just hard-coded one of the serials in here, but you could have the serial log in and then actually generate the serial on the fly, like kind of what we're doing with the Go generator, and just send that off as well. Anyway, that has been how to solve the Ultimate Calculator 3000 challenge. I hope you liked this one. I tried to combine a little bit of web and reversing skills in there, but try and keep it still kind of beginner, intermediate level. And if you didn't see it, make sure you join my Discord server and keep an eye on Twitter and LinkedIn, whatever, for future challenge announcements. Hopefully I'll be able to get some prizes in future from some sponsors. At the moment, I just give out a HackerCat role on my Discord server, but yeah, apart from that, the write-up will be on Gitbook, and if you have your own write-up or you solve this differently, make sure to let us know in the comments and post them on social media and stuff. Yeah, anyway, hope you enjoyed this video. Any questions or comments, leave them down below. Thanks.